Okay, you're going to have a pretty quick video here. You did the secant function as part of your problem of the week, so maybe you already figured this out. But the way we graph secant and cosecant is by thinking of them in terms of sine and cosine, okay? So here's the reason why. If we think of the unit circle, okay, the cosecant of theta is 1 over the y-coordinate, okay? And we know that the sine of theta is the y-coordinate on the unit circle. So that means that the cosecant of theta is on the unit circle 1 over the y-coordinate, but in terms of sine, it's the reciprocal of the sine function. Similarly, the secant of theta is the reciprocal, okay, not the opposite, of the cosine function. And that's how we're going to approach graphing secant and cosecant, is in terms of their sine and cosine graph that they're related to. So I'm going to go ahead to GeoGebra, and I'm going to plot some key points on the sine curve. Okay, we're going to graph cosecant x in a second here. Let me just change my tick marks here so that we can look official here. So I want my ticks to be pi over 6, close. Okay, here we go. All right, so we know that 0, 0 is on the sine curve, and we know that pi over 6 comma 1/2 is on the sine curve. I'm not going to do anything at pi over 3. I am going to do something at pi over 2, so pi over 2 comma 1. I like that dot. I like the dot 5 pi over 6 comma 1/2. And you'll see why I like these dots in a second here. Okay, I like the dot pi comma 0. I like the dot 7 pi over 6 comma negative 1/2. I like the dot 3 pi over 2 comma negative 1. I like the dot 11 pi over 6 comma negative 1/2. And then I like to finish with 2 pi comma 0. Okay, so those blue dots there are on the sine curve, and cosecant is the reciprocal of sine. So what I want to do here is take these y values and take the reciprocals at each of these points, and that'll be a dot that's on the secant curve. Okay, on the secant curve. So I have 0, 0. The y-coordinate is 0. The reciprocal of 0 is undefined. Okay, which to us means graphically you're going to find a vertical asymptote here. All right, so in GeoGebra I have to do it like this. Okay, you don't have to do this, but I'm going to go a segment from. You're going to just draw a dotted line because you can do that. I can't. I got to do something special here. Okay, 0, negative 2 to 0, 2, and let me make it. I can get this up here. Let's see here. Tell you what, let me do this. Make it dotted and red. There we go. Okay. And I'll tell you what, I'll even turn off the axes there. Okay. What about 1/2? Okay, 1/2. Well, the reciprocal of that is going to be 2. Now I think my tick marks are not going to go high enough, so let me change that real quick here so that we can see where that dot's going to go to. Let me go from negative 3 to 3, close. Alright, let me turn the axes back on for us. Okay, so this point here at pi over 6 comma 1/2 on the sine curve, that's going to go to pi over 6 comma 2 on the cosecant curve. Okay, this dot here is actually going to stay put. All right, so let me start to erase the dots that I don't need anymore. That's a dot on the sine curve. So is this. C stays put. Now D goes to 5 pi over 6 comma 2. I can move D. Okay, now what about what happens at E? Well, I got 0 again, so that means there's going to be another vertical asymptote. So You can just draw it in with a vertical line here, but I'm going to go ahead and say, all right, I'm going to go segment negative, this is now at pi comma negative 2 to pi comma 2. Okay, so there's my segment. Let me make it dotted in red so we can tell it apart from everything else. Style dotted. Okay. All right. This point, and I can remove point E now. Point F is going to go to, right now has a y coordinate of negative 1/2, so now it's going to go to negative 2. And I can move F. I can remove F there. G stays put, because right now it's negative 1. Negative 1 flipped is negative 1. H moves from 11 pi over 6 negative 1/2 to 11 pi over 6 comma negative 2. And H can leave. And then back I, you're at 0 again. So that's going to be another vertical asymptote. Let me make another segment here. Segment. There we go. Spell it right. 2 pi comma negative 2 to 2 pi comma 2. So I can get a segment. You just draw it in the asymptote there. Properties. Color. Red. Style. Dotted. Okay, and those are the dots that I can now use to graph the cosecant function, the parent cosecant function. What's going to happen here is you're going to try to connect these dots with a smooth curve. These dots are going to shoot up towards the y-axis, or towards infinity, the closer you get to the two asymptotes, and these dots down here will start to shoot towards negative infinity as you get towards these asymptotes here. All right, let me go ahead and draw in what this actually looks like so you get a feel for it. But there you go. One full period has a branch that opens upward. It's not a parabola, by the way. We know what a parabola is and spent some time with that back in the fall. Parabolas definitely don't have asymptotes. But one branch opens up and one branch opens downward. And you can kind of see, if I put back in the sine curve here, how the flip, the reciprocal, works. Okay, the smaller the values of sine are, the bigger the values of cosecant are. And the bigger the values of sine are, the smaller the values of cosecant are. That's how reciprocals work. And so when we transform a cosecant, we start with transform sine curve and work from there. And that's what we'll practice in class Thursday. Okay, and that ends this will end the graphing portion of the trig unit. And we'll have our graphic extravaganza coming up pretty soon. All right, so for your entrance ticket, still email me 2 questions, and you guys graph the parent function for secant x. See you soon.